Hi, and welcome. You ever wake up in the middle of the night after completing a project and going, oh, dang, I could have done that a whole lot better? Well, that's what happened this time. So if you watched my power feed installation on the y-axis, I came with these stops that are eccentric cams. Essentially, they're an offset screw on a cylinder so that I could have some adjustment range. But I was thinking, there's a whole lot of situations where these adjustments are not exactly where I need them. And they're very limited. They've got about 3/4 of an inch of range, and that's not enough. So I was thinking to myself in the middle of the night that I could do a lot better. And that's sort of what happened here. Because in reality, the actual travel of the y-axis is more than it is right now. Because right now, my milling vise sits off the end of the table normally, and as a result, it collides with the column first. But if I was just milling a piece of flat plate up here, then I could go farther in a Y travel. And sometimes maybe I got something sticking out and I don't want to travel quite as far. So I think I need a lot more adjustment range than I've got. So I've got a better solution. And that's what we're going to pursue this week, because it just bugged me. Even though the stops really don't matter, I could always unscrew this and remove it. But if you're running close to the end with the power feed and you hit that limit, you could either strip gears or damage something else. So I really don't want to. With my x-axis, I take off the limit switches because the travel's so far and I never go that far. But on the rare occasion that I would, I can always put it back. With this one, I think it's a little more necessary because when you're concentrating up top, you're not thinking about down here, and this range is smaller, and I have run into that limit manually many times in the past, especially when I'm doing plate. So I think these limit switches are important, but I need more adjustability. So I think I got an idea. One thing I noticed when I was planning for this was that this hose here for the oiling, from the oiler here, was going behind this just fine, but every once in a while it would catch. And if I'm not paying attention, it could rip that oiling hose right out. So my new solution will be to have a bar that goes from here all the way down, and this will be pressed behind it with a little bit of space so that it can move freely. And I'll be having something that rides on top of this bar, sliding along its edge, that will be used to provide the stops themselves. I got to make sure I got enough clearance here. I guess we'll start with the easy part, 3/4 inch spacers by 1/4 inch hole down the center. This tubing I have here is 1/2 inch tubing with supposedly 1/8 inch wall, but I think the center hole is just a tiny skosh under 1/4. So we're going to run a drill bit through it real quick, just to open it up. Looks like not so much of a problem. Nope. Well, that's good. Then we'll just face it off and cut off a couple 1/4 inch sections. So we'll set my Z knot, and instead of 0.129, which is the thickness of this parting tool, alrighty, and come back, and now we'll go over 3/4. .750. Hopefully I don't have too much sticking out. Now my current position is 0.129. And we need to go over 0.750. Do we have enough? Holy cow, it's going to be really, really close. Holy moly. Considering I was a fool and I didn't measure the amount sticking out, I got really lucky there. There's my spacers. I just need to deburr them and remove the little remaining material sticking on the end. I've got 2 spacers. All right, so I'm back over here. Here's my 2 spacers. They turned out pretty good. I chamfered the inside. These are going to space underneath this guy and lift it up. And there's just enough room for clearance on either side. Ooh, I might have wanted to turn these down just a little bit smaller. These may not work out. I'm going to have this part that slides along here be an 1/8 on each side. They might run into these if they're not perfectly centered. That could be problematic. I just need to turn these down a little bit, diameter-wise, for clearance. But in the meantime, I'm going to find the center of this and go in 1.5 inches and then go down 15 inches more or less and drill 2 holes. And then we want to go down 15 and 1/16 if I have the range. I don't know that I do. This vise is sort of centered. I think that's enough range. And I just want to put a mark down here. Just want to support this a little bit here. And we are just shy. What do you know? Just so this can get in. That looks not at all centered. I need to revisit my calculations. All right, so I'm lucky I double checked my numbers because it turns out I went over 15.625, not 15.0625. Always double check. Measure twice, cut once. Really worthwhile doing. This was just to support it so I can center drill it. Where I've just broken off the end of the center drill. Can't have better luck than that. It's nice I put a little piece of high-speed steel right where I need to drill. So there's a carbide drill, end mill. Okay, cleared out the hole. That worked out pretty good. It's got to run much faster. I think I wasn't going anywhere fast enough for that center drill either. I guess as long as I have it supported, I'm just going to try and drill right through. Just slide everything over a little bit and see if we can go. And no problem. Very nice. Okay, I think we're good to go. Gonna use brass for the stocks. I'm just cutting this material down to size. 1-inch thick brass being cut like butter. Just gonna dimension the brass to size. First I'm gonna cut this side, then I'm gonna flip it 180, do the back side after I clean this side up. I needed to clean up the one side of this. And I have this end mill that I've saved as a side cutting end mill only because the bottom is shattered. And I was wondering if it was gonna work. So this is gonna be multiple tests. I'm going to use my power feed, my Y-axis power feed, and see how we do. It may be out of balance enough that it's not good, but I'm just curious what the finish is gonna be like. So I'll lock off my X-axis and power feed through. I can tell you it's already a much cleaner finish than when I hand crank. It's not perfect, but darn near so. I'm plenty happy with it. Definitely the power feed's an improvement, especially when I do edge cutting like this. So we need to cut a slot down the center of this, about a 1/2 inch deep, ultimately to allow clearance for the screws, not for the T-slot cutter that I'm going to use. That's only going to be 3/16, an eighth down, I'm sorry, an eighth down and 3/16 wide. So the extra depth is going to be for screw clearance that are running along that shaft, since I don't have countersunk screws. So to find my zero, there's a 21 thousandths piece of shim, and I'm just going to take my end mill and hit Z.021, and then I'm going to lift up. I guess we'll do this like 1/8 inch passes kind of thing. We need to ultimately do about a 1/2 inch depth, nothing super particular. So we're just going to cut these real quick. I'm kind of lucky, and I have an entire set of key slot cutters, and I got it on eBay for a really good deal, which was a great find. This one is almost exactly 3/16. It's just a tiny bit over, which is exactly what I need. And we've got my Y-axis and my Z-axis locked off. This should give us an 1/8 inch clearance, which looks right. There's more clearance underneath it. That's for screws. We're going to support this thing just on the slot I'm cutting here. And there's a 3/4 inch slot. So it looks like 1/2 inch plus an extra quarter. Looks like we'll get an 1/8 aside, which is exactly what I want. We're going to run this kind of slow. And we're just going to let it go. I think it should be all right. We're currently going 100 RPM. This being brass, I don't think it needs lubricant. I might come back and do a spring pass just to check it. Wow, those key slot cutters make a really close fit. Holy moly. That is a very good fit. Holy cow. There is almost no slop in there. Just take a little couple burrs off and we're good to go. All right, I think that'll be perfect. Last step, gonna drill and tap for these 1/2 inch 13 set screws. Still in back gear, I guess that'll work. And we're good. Now I just need to cut this guy in half and clean up the sides, which we'll use the power feed for again. It's not perfect, but pretty darn good. All right, so here's the improved version, I believe. I think it's a step up from what I had before. It's a little challenging to put in because I made everything fit pretty closely. Including this side where the spacer just barely fits because, again, everything is pretty darn close, which is fine. All right, so here's my stops, and I think it should just hit them. Yep. Okay, so let's set the stops really close. We'll set them in here. All right, hopefully you can see that. Yeah. All right. And it's off. And it's off. I didn't want to keep going the first time because I was worried about crashing. There we go. Perfect. And so one thing you'll notice about this is, see this guy here? This now fits behind here. Before, it was going to be a problem. Now it fits with plenty of space. So these guys can go all the way back here. It's going to make it a little harder to see, but I need to put the vise in the middle so that it will, just before I run into it. Oh, look at that. I'm not even tightened up all the way, and that shut it down. That's not a bad spot right there. We'll go there. So the set screw even runs into that, which is kind of interesting. That's in the clearance space there because now I can go past it. Okay, that's the end there. So I think we probably want to be ending about here. There we go, perfect. Well, that's it. I think this is much improved over my previous design. This thing doesn't get hung up or accidentally pinched between the eccentric cam that I had on the end. Perfect. I think the design I used there is an improvement over this design. I like these spring-loaded plungers here, which I could add to that design if I want to. I don't think I need it, but I could even reuse these springs or the plungers and everything if necessary. But this aluminum rail sticks out way too much, and it blocks the place for that hose to go behind it. So this is too tall to even fit in there. So I think overall, my solution's a better one. Only time will tell for sure. All right, that's it. Thanks for watching. Hope you find it useful. Hope to see you next time. Hope you like this project.